Alright, let's have a go at this question. It's a B-level standard for maps. It says a tunnel 200 meters long has the cross-section below, where f of x is equal to 5 sine pi on 30 times x. We need to find the volume of concrete needed for this tunnel. So concrete is obviously this shaded region. First of all, looking at this diagram, what's wrong with this tunnel?
It's too very weak.
It's really weak at the top there, isn't it? Okay, and probably not realistic, not practical.
Yes. And it's also very wide. It has very shallow sloping angles. So.
Well, I haven't put a scale on here yet, so we technically don't know how shallow that is. All right. So if we're going to find the area, obviously we're going to need this horizontal function. Do we know what that is yet?
No, we should find out.
Oh,
Yes.
yes.
Find out.
You can find
We
out.
can find out. But, okay, well, let's talk about f then. It's a sine curve, and sine curves look like this. So can we all agree that this is the top half of a sine curve, yeah?
Yeah.
All right, now tell me what this horizontal function is.
Yeah, the top half. The horizontal function will just be whatever sine is at its highest point.
Y equals 5.
5, yes, thank you. Y equals 5. Right, because that's the amplitude.
Oh yeah.
From there to there, it's just 5. And there, from there to there is 5.
Oh.
Wow.
Okay. Alright, next thing we need to know is this boundary right there. Yes,
It's 30.
it's 30. How did you know that?
Because it's pi on 30, and when x is equal to 30, pi on 30 times 30 is pi.
Okay, so you put 30 in there,
Yeah.
and the 30s cancel, and so you found that sine pi, and that's going to be pi is equal to 30. That's true, very good.
Why is x 30?
He chose it because he knew that that point has to be pi. That's pi units for sine pi, so you worked out. So you put 30 in there and you get sine pi, which is that coordinate. I wouldn't expect everyone to be able to do that, all right? So let's use our formula for wavelength. Wavelength formula is?
I know, I should know the two because we do it.
2 pi divided by
2e? 4
E. Really important to know that one, and the reverse is also true. So to solve for b, you need 2 pi divided by wavelength, which is lambda. Okay. All right. So coming back to here, what value is b in our function?
30.
It's not the 5. It's pi on 30. Okay. So we're going to need to rearrange this now, and we get 60 pi divided by pi, pi's cancelled, so our wavelength is 60. Okay. Now, so does that mean that's 60? No. Because that there would be 60, so halfway would be 30. So Aiden just saw that, and that's good for you, Aiden. Well done for picking that up. All right. Let's keep going. So now we have the integration from 0 to 30 on the function 5. Take away 5 sine pi on 30x. 5 sine pi on 30x dx. Now, what's the integration of negative sine?
Cosine.
Cosine. Derive sine, we get cosine. Derive cosine, we get sine. Negative sine. Derive negative sine, we get negative cosine. So the integration of negative sine is cosine. Very good, Ben, which is what you said.
Yeah.
Right.
Yeah,
So we get 5 cosine pi on 30x dx, and we have to divide by the derivative of cosine pi 30x, which is pi on 30 goes here, we have to divide by it. Okay. on the boundaries, sorry, that the extra there. On the boundaries, 0 to 30. Okay. So I can simplify that, can't I? What's that going to come to? Charles, what are you trying to mumble to me?
I'm not sure.
150.
150 on pi, that's right. Okay, so we're going to flip that. We're going to get 150 on pi. And we're nearly done now. So substitute 30 in, and we get 150 plus 150 on pi times by cosine. 30 cancels with 30, so I get cosine pi. Take away, and substitute 0. Now, with polynomials, we know that we just get 0 there, okay? But when it comes to cosine, sine, and the e function, you can't just put 0. True? Right, because even cosine, sorry, sine you can, but cosine, you're going to get 1, okay, for cosine 0. So, let's plug 0 in for cosine, and we get 150 over pi cosine 0. Everyone happy with that? Okay, let's work over here now. So, 150 plus 150 on pi times by cosine pi, which is -1. That makes this value negative. Take away 0, I don't need that 0 anymore. 150 over pi times by 1 is just negative 150 on pi. Okay.
So it equals 150.
Sorry?
Does it equal 150? No.
Close. 300 on pi. Okay.
Oh,
Now, let's just think about this answer for a second. Okay, it comes down. Let's think about the reasonableness of this answer. Look at the diagram. Can you see the 150?
Yeah.
Yep. It's a rectangle, right? It's 5 times 30. So we can see the 150 is there, right? Now, this is a curved shape, which means this area should be in terms of pi. Yeah, so that's another way to sort of check or validate that you're on the right track. So, we're ready to type this into our calculator now. Let's get a value for it. Did you say 55?
95.
Oh,
My bad,
it's
sorry,
54.5.
150 minus 95.
54.507.
507.
And this will be an area, so it's units squared. To answer the question, what is the volume of concrete needed for this tunnel? Well, how long is the tunnel?
200 meters.
200 meters. So we're going to have to say the volume is equal to area times height, which is 54.507 times 200.
10,901.4
10,901.4
meters.
meters cubed. Yes, Swift.
With the, so you have 54.507 like units squared. How come you can multiply that by 200 meters? Because that's two different units technically, unless you state that it is meters squared.
Yeah, because I'm using the volume of prisms. So if you can work out the area of a triangle, then its prism is just multiplying it by its depth. Right? So I'm saying that this tunnel is like this, and we're just multiplying it by its depth, which is 200. Yeah, because that's a cross section.
Then how does it end up with meters cubed? Because you had two different types of units.
Well, the area here is in units squared, And then when you multiply it by its third dimension, it becomes a three-dimensional shape.
Right.
So that's why. Makes sense? Yeah. Okay, pause there.
I'll just make some calls.